Do you believe in robots? Or seat robotics?
Hi, I'm Jayron. There's a trick I wanna show you. I can light the LED using a code. Impossible? Well, let me show you.
The day is clear and the sky is bright. Let's explore the robotics with all our minds. In these experiments, we'll take a dive.
Hi, I'm Kaizer, and I have a secret to tell you. I can fix wires. You don't believe me? Let me show you. Studying robotics teaches you not just how to build and program robots, and also how to think creatively, fix problems, and prepare for future technologies.
Main components. Number 1. Arduino Uno. Number 2. Breadboard. Number 3. LED. Number 4. Resistor. Number 5. Jumping wires. How it works. Number 1. The LED's anode, long leg, is connected to digital output pin like pin 13 or 8. Number 2. The cathode, short leg, is connected to GND, ground through a resistor. Number 3. The Arduino repeatedly sends high on and low off signals to that pin. Number 4. This makes the LED turns on and off in a loop, giving a blink effect. Main components. Number 1. Arduino Uno. Number 2. Breadboard. Number 3. LED. Number 4. Resistor. Number 5. Jumper wires. How it works. The LED is connected to one of the PWM, pulse width modulation, pins on the Arduino, pins with symbol like pin 9, 10, or 11. PWM allows the Arduino to control how much power the LED receives by tuning the pin on and off very quickly, changing the on-time duty cycle. The LED's brightness gradually increase or decrease, creating the fade effect. Main components you can see. Number 1. Arduino Uno. Number 2. Breadboard. Number 3. 2 LEDs. Number 4. 2 resistors. Number 5. Jumper wires. How it works. Number 1. Each LED is connected to a different digital pin on the Arduino. For example, pin 8 and 9. Number 2. The Arduino sends a high signal to one LED to turn it on, while sending low to the other to keep it off. Number 3. After a short delay, it switches. The first LED turns off and the second LED turns on. Number 4. This alternates repeatedly, creating the blinking alternately effect. How it works. Number 1. The potentiometer has 3 pins. One pin connected to 5V. The other pin is connected to G and D. The middle pin whipper connected to analog input A0 on the Arduino. Number 2. As you turn the knob, the potentiometer changes its resistance, sending a different voltage level 0 to 5V to the Arduino. Number 3. The Arduino reads this voltage using the analog read command. Number 4. The value 0 to 1023 is mapped to control how bright the LED should glow using PWM, pulse width modulation, on the digital output pin like D9. Number 5. Turning the knob one way increases brightness, while turning it the other way dims the LED. How the circuit works. Number 1. The push button is connected to the one of the digital input pins. Number 2. The LED is connected to a digital output pin through a resistor. Number 3. When the button is not pressed, the input pin reads low and the LED stays off. Number 4. When the button is pressed, the circuit closes, sending a high signal to the Arduino. Number 5. The Arduino then turns the LED on.
Main component 1. Arduino Uno 2. Breadboard 3. LDR or light dependent resistor 4. Resistor 5. Buzzer 6. Jumper wires. How it works. 1. The LDR changes resistance depending on the amount of light. Bright light to low resistance, darkness to high resistance. 2. The Arduino reads the voltage from the LDR through an analog input pin. 3. If the light level drops below a certain threshold, dark environment, and the Arduino sends a signal to turn the buzzer on. 4. When the light levels goes back, the buzzer turns off. Main components 1. Arduino board 2. Breadboard 3. Push button yellow 4. Buzzer 5. Jumper wires. How it works. 1. The button is connected to a digital input pin on the Arduino. 2. The buzzer is connected to a digital output pin. 3. Normally, the input pin reads low, push button not press. 4. When you press the button, the input pin reads high. 5. The Arduino code detects the high signal and turns the buzzer on. Send voltage to the buzzer. 6. When you release the button, the signal goes low again and the buzzer turns off.
How it works. 1. The Arduino sends an electrical signal high or low through a digital output pin. 2. That signal travels through the jumper wire to the buzzer on the breadboard. 3. When the pin set to high 5B in the code, the buzzer sounds beeps. 4. When the pin is low 0B, the buzzer turns off. This project makes the buzzer beeps in a specific pattern that represent the Morse code for SOS. The first S is 3 short beeps. The O is 3 long beeps. The last S 3 short beeps again. Each beep has a short delay between them to separate the signals properly.
How it works. Number 1. The potentiometer is connected to one of the Arduino's analog pins, A0. As you rotate the knob, the voltage output from the potentiometer changes from 0V to 5V. The Arduino reads this voltage as a value between 0 and 1023. Number 2. The Arduino code then uses this analog value to control the buzzer's tone or frequency. For example, turning the potentiometer might be change the pitch of the buzzer's sound. The Arduino's tone function sends different frequency signals to the buzzer pin based on the potentiometer reading. Number 3. The buzzer is connected to a digital pin and GND. The Arduino outputs a PMWM, a fluid width modulation signal that makes the buzzer produce a sound.
How it works. A. 7 segments display has segment labeled A to G. By lighting a specific segment, the Arduino can form any number. For example, to show 1. Only segment B and C are on. Each segment is connected to an Arduino digital pin like 2 to 8 through resistor. The Arduino code sends a high or low signal to each pin to control the LEDs.
Number 1. The 7th segment display has 7 LEDs labeled A to G. Each segment is connected to a digital pin on the Arduino, for example, pin 2 and 8. By turning on specific segments, you can form digits. Example, 0 lights up A, B, C, D, E, and F. 1 lights up B and C. 2 lights up A, B, D, E, and G, and so on. Number 2. The Arduino code uses a loop to turn on and off the right segment in sequence, showing each number one by one. Number 3. The display counts automatically, meaning the number changes every second delay, like 1 second. This is done using the delay function or a timer in the code.
sa delete ni Kaizer, suntukin sa akin.
Through the Arduino activities, we learn how to connect circuit and write simple program to control components like LEDs, buzzer, and button. We gain better understanding of how input and output work together. The main challenges we face was wiring errors and code mistake, but this helped us improve our problem solving and patience. Overall, this experience taught us that basic of electronics and programming is fun and hands-on way.